Okay, so section 5.5 is called the substitution rule. Before we begin, we're actually going to break this section into two parts. So today we're just going to be learning the substitution rule with indefinite integrals, which means that the integral does not have any interval values given. So it's just going to be learning the process today. And then with the next video, we will dive into how we can use it to evaluate the area under the curve. Okay, so basically the idea is we have an integral that we can't integrate because it's too complicated. So what we're going to be doing is using substitution to make something that looks complicated into something that's not complicated. So the way that this is going to work is you're going to establish a new variable, and you're going to make that new variable represent something in your integral. Now, typically the something that you choose is going to be something that is inside of a radical, something that's inside of a trig function, or something that's in a denominator. That's the most common choices. And so what this means is that you're going to modify your integral. And so when you decide, that the inside is going to be called u, and you rewrite your integral with that u in that particular place, already you've made the integral look a lot less complicated. Now the issue at this point in time is that I can't really integrate yet because I have x's and then I have u's. So not everything's on the same playing field, if you will. So your next step then is going to be to figure out how you can change everything into u's. We want everything to be the same variable-wise, so that we are all, we're analyzing everything in terms of one variable. All right, so let's go back to our u that we chose. So I am going to, for the next step, I'm going to take the derivative of u, and I'm taking the derivative of u with respect to x. So we would call that du dx, and the derivative would be 2x. Okay, now what you're going to do is you're going to use some algebra. So I'm going to multiply by dx to rearrange this equation. Okay, now look at what you've just created. You've made a derivative and you've moved things around to create an equation that says that du is equal to 2x dx. That means 2x dx, which is in the problem, I can put du in place of that based on this information. So now my integral looks like radical u du. Everything is in terms of u, so you can now go ahead and actually take the antiderivative. I think before we take the antiderivative, we are probably going to want to change that to u to the 1/2 power. And then we're going to do the add 1 to the power, which makes it 3/2, divide by the power. Don't forget plus c. Dividing by 3/2 is the same as multiplying by 2/3. And so there's our antiderivative. The very last step in the substitution rule practice is you need to change your u back to what it was originally. So you need to change it back to x's. So the x, or the u, was 1 plus x squared. So I'm going to plug that back in place of u, and I have my antiderivative. Okay, so that was kind of a lot. Let's see if it actually worked. So let's go and let's call the antiderivative, the answer we just got, let's write it back down and let's check it by taking the derivative. So if I take a derivative, I have to multiply by the power, so that's going to make it 3/2 times all this stuff. Subtract 1 from the power and we get a 1/2. And then don't forget you have to multiply by the derivative of baby, which would be 2x. The derivative of c is the same as saying, what's the derivative of any constant value, which is 0. So that would be gone. 3/2 times 2/3 is equal to 1. So basically these guys cancel each other out. You have a 2x and then you have your 1/2 power with all that stuff on the inside, and that is the same as saying the square root. So basically that did give us our original equation, therefore our antiderivative solution was correct.